All right. And please have your formula sheet out because we are going to be talking about a couple of these formulas as well, a couple of these formulas. All right, so breathe in, breathe out, breathe in, breathe out. Okay, so chapter 19 is thermo, okay? So thermo is going to hit us again from first semester. We did a lot of exo and endo and all of those things. And again, you probably need to go over a few of those things before you get to the AP test. But in chapter 19, it is talking about something called delta G. And delta G is called Gibbs free energy. And that's going to be, again, the big theme that we're going to see. So we need to talk about, is a reaction spontaneous or not spontaneous? And please know, I put this in my video, it doesn't mean it's instantaneous. So when we're saying spontaneous, as in a normal human being thing, we think that that means we're doing it right now. That doesn't mean that's the same for chemistry. Chemistry means I don't have to do anything to it. When I put the chemicals together, they're just going to react. I don't have to do anything to it. So I gave you a few examples of this. So when I mix an acid and a base, I will get a reaction. I don't have to do anything to it. So we're not saying we don't have to mix them. We still have to mix chemicals in order for a reaction to take place, but I don't need to do anything to it. So I don't need to heat it. I don't need to change the constructs of it. It is just going to happen. But then something like the electrolysis of water, I have to put energy in. I have to put electricity in to do that. Or taking out an ice cube, putting that out on the table, I will get that to melt because there's enough energy in the room. So spontaneity has to do with, again, will it happen without me doing something to it? So how do we know if something's spontaneous? Well, there are two factors. One is enthalpy, which is delta H, which we've already talked about, but the other one is entropy. And I've kind of danced around entropy along the way. We talked a little bit about it, but entropy is chaos, randomness, disorder, okay? So S that you're going to be looking at is looking at a chemical reaction. You're trying to determine, is it becoming more disordered or becoming more ordered, okay? This is one of the factors that determines if it's an overall spontaneous reaction, okay? So when we are looking at S, it's only one of the things that we're going to look at. But the thing that you can look at is state of matter, okay? So you have more chaos with gases because those particles could go wherever they want. You have less chaos with solids. They are much more ordered in a pen. So there are rules associated with entropy having to do with when you look at a balanced chemical equation, can you tell if the entropy is increasing, decreasing, or remaining the same? So I'm going to walk through an example or two because these are easy questions they could give you on especially the multiple choice section because you're not going to have a calculator. So this could just be, here's a balanced chemical equation. Can you see if entropy is increasing, decreasing, or remaining the same? So the examples I gave you here, I have something in a solid form going to a bunch of gases, okay? So anytime you are going from, say, a ordered system to a less ordered system, that's going to mean entropy is increasing, okay? Entropy increasing is going to make it a positive value. So you're going to see a positive value if something is increasing in entropy. The other thing you could look at here is the number of moles. So I have 2 moles on the reactant side going to a total of 7 moles on the product side. So if I have more stuff, that's going to mean I have more chaos or more instances for having more disorder. So anytime you have something like this, or you could say this is a decomp reaction, that's breaking things up into multiple things. That's also going to be an example or an explanation you could use to determine if entropy is increasing, decreasing, or staying the same. The second example, you would say entropy is decreasing because you are going from 3 moles to 2 moles. I don't have any different states of matter there, okay? So I don't really have solid to liquid or a gas going to liquid or something like that. So I really just have 3 moles going to 2 moles. You could also say this is a combo reaction, meaning I am making a substance from something else. So just because I'm reducing it down to one thing from 2 different things, that's going to mean entropy is decreasing. If entropy is decreasing, we're going to have a negative sign associated with it. So that is entropy. So you are skipping, and I told you this in video 2, you're skipping second law of thermodynamics. You are skipping all of that. La 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 la. So I wanted you to skip to number minute 7 in that video. Nope, that's not what I wanted to do. So we are going to talk about something called Gibbs free energy. And Gibbs free energy is really the how you answer if a reaction is spontaneous or not, okay, is G, okay? And G is going to be delta H minus T delta S, okay? This is on your formula sheet. Okay, that is on your formula sheet. So no need to memorize, no need to worry about that. This is enthalpy, which is what we learned in first semester. This is entropy times temperature, because if I have more and more, a higher temperature, you're going to have the ability for the substance to have more chaos because it's going to be moving around more. So that is why temperature is always linked to entropy. So spontaneity has to do with delta G. If your delta G is a negative, that is a good thing. You want a delta G to be negative. So that means it is spontaneous. If delta G is greater than 0, meaning it is a positive value, that means it's non-spontaneous. And you could reverse the reaction and then have a spontaneous reaction, depending upon the situation. If delta G is exactly at 0, that is going to mean that it's at equilibrium. So you don't necessarily have a change there at that moment of time. So here is the big challenge, okay, is this table here, okay? And you understanding how delta H and delta S are going to be related, okay? So this is going to be where you have a lot more thinking to think through in terms of this equation. So you are trying to get delta G to be negative. That is your goal, okay? So if I have delta H and delta S in this equation, if my delta H is either exo or endo, if my S is either positive or negative, that delta G is going to be affected. So these 4 circumstances are what you need to understand when you're given a balanced chemical equation. And they ask, is this reaction spontaneous? What you have to think about is, do you have information about the delta H? Do you have information about the delta S? Okay, and in that combination of negatives and positives, can you determine if the delta G is going to be negative? So the best situation you want is exothermics. Exothermics are always favorable because you are releasing energy, and you want more chaos. So you want delta S to be positive. So that means this situation, if you have an exothermic and an increase in entropy, it will always be spontaneous. If you have an exothermic and you have a decrease in entropy, meaning it's becoming more ordered, it will be spontaneous at low temperatures. And that is because, and I went through this in the video, if my T is at low temperatures and my delta S is negative, that will keep the negative H, or excuse me, yeah, the negative delta H to be big enough so that when I calculate it, my delta G is still going to be negative. So that is why I want my temperature to be low. So it's really you evaluating this, excuse me, equation to get that delta G to negative. If I have an endothermic process and it is an increase in entropy, that's a good thing. It's going to be spontaneous and only high temperatures. So I want this part here because, again, the S is going to be positive, and so you have a negative T delta S. I want this to be a very big number so that it could overcome essentially your positive delta H, so that it will end up being a negative delta G from that. What will never work is if you have an endothermic process and the delta S is decreasing, meaning you're becoming more ordered. That will never be spontaneous. So this is one place in chemistry, always and never do apply, okay? Where you can say it will always be spontaneous or never be spontaneous. So the examples I gave you in the notes here, what you have to do is, depending upon the information given, you're either going to determine the delta S by looking at the equation, looking at the delta H to see if it's positive or negative, and then from there determining if the delta G is such. So with this example, I have all gases. I have 4 moles going to 2 moles. So my delta S is going to be a negative value. So my delta H is also negative. So if I plug this into my delta G equation, my delta S being negative multiplied by a negative is going to make that a positive value, okay? So if I want that to work and that my overall is going to be negative, I want my T to be low. So I'm going to say that this is spontaneous at low temperature. Well, the second example, I'm going from 4 moles to 1 mole. They're all, this happens to be a solid. Doesn't really change anything about this. My delta S is also going to be negative, but my delta H is going to be positive. It is given as an endothermic process. So this is going to be negative T, negative delta S. So this becomes positive. This is positive. There is no way I can make that negative. There's absolutely no way I can make that negative. So you're going to say that this is never spontaneous. Never. All right, so I'm going to pause there for a second. Any questions on that? Yep. Okay. Okay. Temperature is always going to be in Kelvin. So you are never going to have anything that is a negative temperature. Okay, so that clarifies. And in terms of low temperature, that is a generality. So it depends upon the numbers. We're not going to do any calculations. They never ask you to do any calculations, but if you had like this number, you could actually calculate in delta S and numerically. So there would be a magical temperature that you would have to be below in order for that to be spontaneous. So that's why you just hear the term low or high temperature because of that. Okay, are we good? Okay. All right, so you can turn to the next page. Entropy can be calculated as products minus reactants. So the good news about all of these calculations is they are exactly the same as what we learned before. So it's always products minus reactants. They tend not to do anything with calculations associated with delta S. But do realize that if you're given a balanced chemical equation and you have the same number of moles on both sides and everything's the same state of matter, and you say that maybe the delta S is remaining the same because of what the balanced equation is, you could actually, there are values for S that you can do. So you can calculate a delta S. I am not going to spend any time doing that because it's never on the AP test. Instead, they give you a balanced chemical equation and say, okay, would you predict entropy to change and why? Okay, so if they give you something, it's always products minus reactants, again, looking at the balanced chemical equation. We did these calculations before with delta H. So there's absolutely no difference, it's just an S. Okay, so again, I'm not going to spend any time on that. Also, delta G, you could find delta G mathematically using many different formats, or there's many different ways of calculating delta G. One way of calculating delta G is if you have delta H and S is given to you, you could find essentially the overall delta H and the overall S, and then you could calculate the delta G. So for this one, hold on a second. So take out your calculators. I just want you to check yourself on this one. I am going to give you the delta H for this. And again, it's products minus reactants. So I don't want you to spend the time doing it. So I'm going to give you the number. It's negative 112 kilojoules. But I do want to show you something that you might encounter. Delta S is going to be negative 147. So again, all I did was I took this balanced chemical equation, I took products minus reactants. So again, I'm just kind of speeding up the process here, The one thing you need to be careful about, and you're going to see this in another calculation I'm going to talk about, is delta H is given in kilojoules, okay? And delta S in a lot of cases are given in joules. So when you are trying to do your delta G, you need to be careful that you convert to one or the other when you're doing the calculation. So see if you can find the delta G using, again, this is at 25 degrees Celsius. This is at 25 degrees Celsius. So see if you could calculate the delta G, please. See if you could calculate the delta G. So you should have ended up with the negative 68.19 or approximately close to that. I converted my S into kilojoules, so I did everything in kilojoules. You can convert the delta H into joules and then convert it back. But generally speaking, that's the one little, not tricky thing about this calculation, but you do want to be aware of units because sometimes you will see kilojoules, sometimes you will see joules. It just depends on the situation. Couple things to point out here. First off, if it is negative, you could say it is, yes, it is spontaneous. So don't lose a point on the AP test by not saying, yes, it is spontaneous and doing all of the math and then not answering the question at hand. The other thing I want to point out is you will see a little degree sign on these calculations. That means it's at standard conditions of 25 degrees Celsius, 1 atmosphere pressure. I am not going to spend any time, and the AP test does not do as well. when it's not at that standard condition. But you can do delta G calculations not at standard conditions, and then you have another calculation to do. But for all intents and purposes, that is one way you can calculate a delta G, is by taking the delta H and the S and putting it into this formula. Okay, so that's one way you can do it. All right, so I have a question. Is the formation of rust spontaneous? Yes, it is. Because technically speaking, if you are having a reaction outside with water, natural circumstances, that is technically considered spontaneous. All right, so